is false, then we've proven that it's invalid. Now, you say, you could go through this whole thing and you could spend like 64 lines, 32 lines, what was this one, 16 lines? Mm-hmm. A mere 16 lines, that's hardly anything, right? I mean, it's not fun till he gets to 32 or 64, right? Anyway, and so what happens is, though, is that as far as it goes, if you get to that where it's like that many lines, yeah, it takes forever, and you could find on line 32 that there is true premises and a false conclusion. And that will be very annoying, right? But there is what we call an indirect method, in which what you do is you assume the premises are true and the conclusion is false, and then you see if you can prove that. And we won't talk about that right now. I might do an example of that right at the end here, but we don't have to do that. It's usually, a lot of people find that method to be a little bit confusing. I personally think it makes it more fun. But, you know, I also am a sick person, apparently. Anyway. So what happens, though, is, yes, there is that case. The only answer is, on really long ones, you're best to use like an indirect method. And that's the case. So anyway, so what happens here is you can use these. Basically, all truth tables it's as simple as that little table I gave you, right? All those 5 little tables. You then plug it into these larger equations, these larger statements, these larger compound statements, right? And you then find the truth value for each line, and you use that to assess the argument, okay? And it doesn't matter if there's 16 lines or 4 lines or 32 lines or there's 87, 256. It always has to be a multiple, something squarable by 2. But the case is that no matter what it ends up being, you will always have it is really no more difficult than just go through your order of operation, look at the chart, and fill in the right number or right letter, T or F, right? It's all fairly simple. It's just it gets kind of confusing when you get in there. And one of the things I say is, like, the hardest thing about this for me is it's sort of like when I also teach journalism, okay? And I used to be a copy editor, okay? And some of you are like, you were a copy editor? I've seen your writing. No. No, it's because I don't have somebody copy editing my work. And that's always kind of the rule. It's like everybody needs a copy editor, even copy editors. And trust me, like, you write headlines and papers and nobody looks at them before you go. And it's always like a huge, like, 70-point, top of the page misspelling. And you're like, oh my goodness, what the hell was I thinking? Because you change it like 6 times and nobody checks it before it goes out. And in your mind it worked, but in the front of 150,000 printed newspapers, it is not correct. And then you feel like an idiot. But that's a whole other issue. But one of the things is when you're a copy editor, one of the things is it's very easy to get spelling errors and other things into a paper, right? And what happens is you need to have a method when you're copy editing to avoid those. And so, it's a matter of, you have to be very careful. You have to slow down. Your brain works faster than it should, right? And you think everything's in line, but you make a mistake. And so one of the things about copying is you have to learn to go back, and, like, one of the rules I used to always use was you always read everything backwards. Like, if you have a headline, you always have to read it backwards. So if it says, like, dog bites man, you read it and you go, man bites dog. Because when you read it backwards, it actually forces you to look at each word individually instead of just being charitable and realizing that words misspell or other things. And so that's what I would say is one of the things that's best about truth tables, one of the things I find most frustrating, but also one of the best benefits of truth tables, is they force you to be particular, right? Because if you get one T or one F out, suppose you have, 4 variables, and there's, like, it says A horseshoe D, C triple bar B, A triple, and you got 16, lines you got to fill out, and you've got, 32 lines, and then, there's, columns, there's, 25 columns. You've got 16 times 25 is 400 T's and F's on the page, right? And you get one of those T's or F's wrong, and you can screw up the entire thing, right? And that's what's always fun when I'm grading is I will go back and I'll be like, okay, where'd they mess up? And I'll look at their work and I'll say, oh, they messed up this one spot and it messed up the entire thing, right? And so that's the only thing. But by and large, when you're in that, it's not that difficult. What I always kind of use the example of is when you're doing truth tables, it's sort of like everybody here from the Springfield area, but like when you go to like Chicago, right? One of the things I find like people from like really small towns, like they'll go like I actually live in Decatur, but I've lived in St. Louis, I've lived in Chicago, stuff like that. And one of the things like when people from really small towns are like, there's so many people around you, and I'm always like, but even if you're in Pawnee, there's just 4 blocks, but it's no different in Chicago. It's just there's 4 blocks beyond that, and 4 more blocks beyond that, and 4 more blocks, and for the next 200 miles, right? And so it's no different. It's the exact same lifestyle. Everybody's the exact same in your block. There just happens to be a lot more blocks around you, right? By and large, people are people everywhere. They're not really that much scarier in St. Louis or Chicago. Maybe. They're no scarier than parts of Springfield. There are parts of Springfield I think people are scary in, right? What's that? Everybody in Decatur is great. I used to work at the paper there, and like I was, it's like after a certain hour, like you go out to my car, I'd be like, gonna make a run for it, because it wasn't like, it's like right at the edge of, like the street I used to work on when I first started about 12 years ago, I started at the paper, and I worked there for like 8 years or something, and the street, when I started, there were like, half the houses were boarded up or torn down, and there were about like 20, 30 houses. And now I drove down that street like about a year or so ago just to count, and there were like 12 houses left out of 30, And that was 60 original houses. And so like whenever I would work, I'd always be like, gonna run to the car. But by and large, yes, there are areas you don't want to be in, but by and large, people are people. There's more of them, right? And so the same thing is true when you're in the logic problem. It's no different than being in your neighborhood in Pawnee versus Chicago. It's just neighborhoods, just people. It's not really that much different. People are comfortable there. It's not that scary. It's just sometimes people look at it and they're like, oh my God, this stretches on forever, right? But the reality is you just need to focus on where you're at the moment, and it's really not any scarier than being in Springfield. I know people from Pawnee who are scared to come to Springfield, right? And there are parts of Springfield I'm scared to go to. I'm not going to kid you about that, but and there are parts of Decatur I wouldn't go to after dark, but that's a whole other issue.
Why would you do this versus the one above it? This is way longer versus what we did earlier.
Well, the one above it, like what I showed you, is if you know the truth values of the letters. If you don't know the truth value of the letters, then we're going to evaluate in what situations it's true and what situations it's false.
Could you just write this down and see the values and...
You could do it, but it would take a lot of paper. What I'm going to show you, and we'll do a couple problems here now, but what these truth tables do is they basically allow you to look at every very possibility. You're looking at every possible scenario of what the truth values are. I showed you the first one.
There's more than just these 5.
No, it's just those 5. But what I showed you with this, where I said, assume A is true, and assume, B is true and C and D are false. When I showed you this, that is where I told you what the truth values were. But if I don't tell you what the truth values are, and you're just going to have to guess, like what situations is it true, what situations is it false, then that's when you do the full truth table. And why would that be important? Because you can actually determine validity, and you can compare statements and do some other things by doing that. Okay? So let's do some of these problems, because now I feel like I've talked this to death. We really need to do something. When I first started the paper, I used to know, when I first started there, I'd know where every murder occurred, and I'd drive around and be like, oh, somebody got shot there. Oh, the mailman got shot there, and the mailman was buying drugs, and that's why he got shot. But, anyway.
The paper reported on, right?
What's that? Yeah, we would report on it, right? But I used to know it all, and then after a while, there were so many murders that I just, lost track. But, it's like that in Springfield, too. Are you leaving?
I have to go take a picture.
Oh, that's right. Okay.
We're a bit close.
Good luck. All right. So the book says you're supposed to do 5.8a, which is on page 146. And 5.8a is just basically just those truth tables I already did, so I'm not going to do that. But 5.8b gives you a series of statements we then use to do these. So, like for example, number 1 says R plus bar S. Everybody agree that that's what it says?
Correct.
Okay. So how many lines are we going to need to look at every possible truth value for that? 4. And so how are we going to assign these? R is going to be T, F, T, F. And then S is going to be T, T, F, F. Right? Everybody agree on that? Okay. So what we would do is the first thing we do is there's sort of an order of operation. You always do any bar that is in front of an individual letter. Okay? Because this is one concept, you know, like as an idea, is one idea. So we need to now find what that bar means. So if S is true, then bar S is false. And if S is true, then bar S is false. And if S is false, bar S is, and we can just do that there. Then what we usually do is I always just say put a line through it. Don't scribble it out. Don't do anything more. Put a line through it, though. And the reason is that way your eye doesn't track to it. But also don't scribble it out because you might have to check your work. So just put one line through it. It's nice and easy, right? Now we're going T plus F. Is T plus F true or false? It's false. F plus F is? F plus, or T plus T is? And F plus T is? So we then, usually what I say is you don't have to cross out the last set. I usually just say circle the last line. And that way you can see what that last line looks like. So it says FFTF, which means this statement is only true if R is true and F is false. Or I'm sorry, S is false. Okay? That's always a little bit of a problem when talking about logic and doing this is like, you know, it's easy enough to be like, R is true and T, you know, you have so many letters and you start screwing them up and it gets confusing. I was observing a colleague of mine teach this one day, and he sat there and did this, and I'm like, I would have tongue twisted about a dozen times, and he did it perfectly, and I thought, he's just better than me. That's fine. I'm okay with that. So, number 2 is P wedge parentheses Q plus R, right? So how many lines are we going to need? 8 lines, right? 2 to the power of 3 is 2 times 2 times 2. And so it's going to be 2 times 2 times 2 is 8. So we're going to start off, and P is going to be true, false, true, false, true, false, true, false. Everybody agree on that? And then that means Q is going to be true, true, false, false, true, true, false, false. And R is going to be 4 trues and 4 falses. And it helps with lined paper, but I don't have lined paper here, so sorry about that.
So anytime you're setting up these problems, it seems like you've got the pattern here where you're doing the true, false, false,
Yeah.
in the very first letter,
Yeah.
and then
The next one.
the same pattern with the second, and this pattern with the third. So no matter how you'll always set your problem up this way, basically.
Yeah. Now there's going to be an exception if you have the same letter twice in the same statement or same problem. Then you need to make sure they match. But we'll come to an example. Like
Okay.
that, okay. So what happens is is Q plus R is, it's hard to read up there, but it says true plus true is true, and true plus true is true, and all of the rest has false plus true